Hi, my name is Gavin Woolery. You can follow me on Twitter at GavinW if you're into that. So what is Voxel Quest? Voxel Quest is a single-player isometric procedural emergent voxel-based, of course, roguelike, tactical, turn-based RPG. I know that some of these buzzwords are kind of getting increasingly popular, but I've been a fan of these things for a long time, probably over 10 years, if not longer. So I'm not just jumping on the old bandwagon. More importantly, it's not really just about what I'm making, but there's a strong emphasis on modding in this engine, so I'd like to see what people can come up with. Since it's really designed to be around a turn-based game that's inspired by board game mechanics, it's really best suited for people designing those types of things. It's also, in essence, a simulation, so it would be good for creating sort of Dwarf Fortress-esque games. That's kind of where this game is going, but I wouldn't exactly compare it to a clone of Dwarf Fortress. So the thing that I'm most excited about probably is the AI. At this point, it's really just the core rendering engine and a lot of the procedural generation and world generation stuff, but in the coming months, I'm going to be working on the AI a bit. There are a lot of games that are trying to tackle this problem of emergent AI, but so far no one's really showing anything. The one exception that I read about is Clockwork Empires. They actually seem to know what they're talking about. I haven't seen their engine, so I can't say for certain, but what they said or what I read about sounded promising. So I totally understand if you're skeptical when I start talking about AI. I've been prototyping AI for the past decade or so, and this hasn't been like intense work or anything. This is maybe me messing around on paper or writing a little bit of code. But I've put a lot of thought into it, and I think I have something that is, pretty simple overall. The concepts are simple. It's all based on prior art. Just a combination of AI techniques that's effective enough and performant enough to be feasible. So we'll see if it works. But what I'm really doing that's a bit apart from what anybody else is doing that I know of is focusing on story mechanics with regards to AI. So I'm really kind of rethinking the way role-playing games are designed. And, what I'm doing isn't just focusing on combat, but rather storytelling mechanics. So if you look at classic storytelling mechanisms, it's really about characters and character personalities and typically character archetypes. There's a lot of character archetypes that are probably cliche, but we still use them over and over anyway because I guess they have some sort of fundamental, deeper meaning or something that's genetically embedded in us. I provided a list of archetypes on my webpage, so I'm not going to go through all those here, but basically, I really want to focus on the sort of role-playing in a role-playing game, and in a way, encouraging you to play a role through using game mechanics without necessarily forcing you to do everything that role would be designated for. So, in fact, there's probably certain circumstances where you might take an action that goes against the nature of your role, which is actually in itself a storytelling mechanism. In traditional pen and paper RPGs, it's kind of free form, and everything's governed by really what the players do, and how they sort of pretend. That might be governed a little bit by a game master or something. But I really want to create a more rigid structure that enables storytelling as actual game mechanics, and fulfilling roles provides its own reward, whatever that might be. Okay, so you're probably tired of me droning on about AI, so I guess we'll talk about something else. So as for the basic game mechanics, it's really inspired by a lot of sort of collectible card games like Magic the Gathering, or if you've played Blizzard's Hearthstone, there's a lot of concepts that will be familiar to you. It's also inspired by tactical games and tactical RPGs like Fallout, XCOM, and so on. What else? So let's talk about what's going on in the background here. Um, so the engine supports multiple lights, colored lighting, um, all of that stuff. Pretty typical. It's deferred rendering, soft lighting, ambient occlusion, refraction, reflection, radiosity. Most of the stuff is obviously performed in screen space since it's deferred rendering. You can also select any of these building segments and toggle them on and off, as you've seen. You can do the same with trees, pretty much any object. So you'll notice that everything sort of loads in these chunks, which is common in voxel games. Basically, you load in these cubic chunks of data based on their proximity to you. Just about every single voxel game does this, from Minecraft to whatever. So one thing you'll notice is that it doesn't really fill up the whole screen right now. Probably by default you'll be zoomed more in, but it is still early stage, so we'll see how things go as it progresses. One limitation is also memory and GPUs, which is set to increase a lot over the coming years. Right now, your average higher end GPU probably has somewhere between 2 to 4 gigabytes of memory, and I expect that to match up with consoles over the next couple of years. So you should start seeing cards with 8 gigabytes of memory pretty regularly, but even still, this will run on cards that are a lot less powerful than that. One of the great things about it is that you can scale down the resolution of the voxels to take up less memory and also perform faster. So all of these building parts are designed to specially intersect with each other to be kind of seamless and provide correct intersections. You'll see when I remove this building segment here, for example, see the dock wasn't normally like that, but it curves itself off a little bit at the end after I removed the building that intersected it. And this applies to building segments intersecting with themselves or roofs or pretty much anything. And you can write special rules for the intersection. It's actually all really simple. And all of this stuff you can modify too. Really everything is being generated within the shader, so you can change the spacing of the wood slats, how big the bricks are, the size and color of the roof tiles. You can remove the plaster from the walls. You can change pretty much anything. It's actually, I wasn't planning for the engine to be this flexible. It's just kind of a side effect. So it's really pretty cool. Okay, so coming up, I'm sort of demoing some of the shader hot loading. So what we're going to do here is just change some of the parameters in the shader. So we're going to change it so that if the final material, the resulting material is brick or it's plaster or whatever, we're going to change it to glass. So this ends up making most of the walls transparent besides the support beams. So it's just one really simple example of what you can do in the shader, and you can just refresh it right as the game is running, which is really great for both, me testing out new materials and stuff and adding materials, and it's great for players as well if they want to modify things. So as I mentioned earlier, you can change the resolution of that the voxels render at right here. It's doing 32 voxels to a side, or 32 voxels cubed per meter, which is about 32,000 voxels, I think. So this basically allows you to render at a sort of higher level fast. You're not getting it as fine-grained details if you zoom in there, but there's also, you can see some sampling errors because it can't quite get really thin samples like the plaster on the walls, so you see some parts of the brick stands out, but it's still really good for getting sort of overall view of the map. Probably eventually it will just be able to toggle resolution on the fly, but right now you have to reboot the program to change the resolution. So you can do a variety of resolutions. Here's 64 voxels cubed per side, which is lower than the default of 128, but it still looks good. It's good enough that you can make out a lot of the small details. Still a little bit loss of fidelity, but overall it's pretty good. So right now these trees look kind of cartoony, which was intentional. I don't want everything to be perfectly realistic. I sort of want some stylized elements. There's a lot more variations that can be done with the trees. They don't have to look sort of like oak trees with random limbs. It could be more uniform. There's any variety of rules or grammars that you could apply to them. So here's more adding and removing building segments. Eventually you'll be able to place building segments wherever you want, and construct them using resources and so forth, which is pretty typical for any sandbox type game. But one of the things that's great about it is that these intersections, I didn't really manually program them that much. They're all kind of a result of the way Boolean geometry works. So a lot of the sort of tricky work in doing intersections and corners and things like that is taken care of for you by the nature of it being volumetric. Okay, and last of all, this is rendering at a really high resolution of 256 voxels squared per cubic meter. So you can really see a lot of detail, and it doesn't go any slower. It's just that you can load less of the world at a time, and at the current state with what memory is limited at, you can't see that much at a time until I improve the way things are kind of cached and loaded. Right now there's no sort of caching going on. There's a ton of room for optimization, so hopefully I'll get that stuff in soon in the future. I can load bigger scenes in. So that about wraps us up. Thanks for watching. Hope this wasn't too boring, and please spread the word if you can. Thanks.